Hi everyone. Today we are going to start to a new topic in Python programming language, okay? Which is called the classes in Python programming language, okay? Firstly, we need to talk about what is class in Python. Class is a simple data structure, okay, which is used to perform specific task with its method and also attributes, okay, which means that we can keep any method or the function or any attributes or the variables to be applied on the specific task which is given in the case study, for example, or the mechatronic engineering problem, okay? And so this class collects all the features into the one object. And so if we can create this class in terms of the variables or the objects, and then we can call it or we can use it in in a manner of the some specific task. For example, a calculation of the summation or the multiplication or the sum writing operation to the Excel file, okay? And so in Python we have basic syntax like this one. We have the keywords of the class and we should give a specific name in here like this one, and then after that we can call or we can state the sum statements or the expressions in order to build your class for a specific task, okay? And so firstly can give some examples in here like this one. In order to define the sum class, we can collect these terms or we can pass this nomination like this one, okay? And so we can call it the sample as, and then if I run this code, there is no error in this code. And also we defined the sample class in here, okay? Just remember that the pass is like the new line character in the C or C++ programming language, or this operator, double or the dot comma operator, which is given in this form. But in the simple syntax we can define this term like this one, okay? And so this sample class is created, and then we can call the constructor of this sample class, and then we can assign the as, and so we can create any object or any variable like this one, okay? Or we can create these terms like this one. The print sample class can be given in here with set statement of this class, and so the foo self and print foo can be given in here like this one. And so we can also give another function like this one, the print bar, okay? And so if I run this code, there is no syntax error in here, but in runtime we have the sample class print object in the terminal page, which means that if we have this class definition, and so we can call some basic functions in the class definition. But if we want to use the foo on the bar with the specific definition, and so we should define this call. In later I will explain detailed the self keyword or the variable which possessed in the sample class in here. And so this is like this keyword in C or C++ programming language, okay? And so in second place we can expand our example in here like this one. For example, we have the class sample in here like this one. The x can be defined in here, and after that the def foo with the self objects should be given in here like this one. And so def bar self and print bar can be given in here. After that, within the class we can call the print x function. And so if we have this nomination, and then we can define any specific function or the variables in the class definition, And even if this sample object is not created in here, and so this print is running, because in Python programming language we have the up to down runtime code, or we can interpret all the codes by using these terms or these rules. Okay, and so if we have this nomination, and then this x can be defined in here, and after that we can call the print function in here, even if it's stored in the class sample. Okay, and so if we have this like of information, and then we can call the foo and bar, even if we create the this function body or the object of these classes. Okay. And so in the third place we have the this, just create the the simple object in here like this one. But firstly we need to talk about the type of this sample class. Okay, we need to talk about it. The type of the sample class is the class of type. Type class means that every class and objects can derive from the this type class. And so this like the Adam or the Eve for the the Python programming language class structures. Okay, and so in every class in Python, and so it's derived from the type class. Type class is the basis of the whole of these classes, and so this class interpret the whole class example or the variables by using these terms, and then you can create the specialized blocks or the function or the methods by using these terms. Okay. However, if we can create some object in here by calling the constructor of the class sample, and after that we can print the type s like this one, and so we will have the main sample body, which means that this is an object, but this object is directly related to the main sample class body. But this sample is a generalized name for the whole total class implementation, and so it's type of the type class. Okay. And so in class each method has one parameter which we call it the self. Okay, in the previous examples we have shown these terms like this one, the sample can be given in here, and so we should give the self function body in here. Okay, foo, and also we can give the self print bar in here like this one, and then this self contains in the class each method has one specific parameter in here which we call it the self. Okay, and self kept the whole variables of the class. Okay, and so this object of class can be given, and this is like this keyword. The class own this parameter for for kept its values for each object. Okay, CPP. Okay, and so a sample can be created like this one, and so in order to call any function definition within the class we should use the dot operator in here like this one, and so we can call the bar function in here, and we can call the foo function in here like this one. Okay, but if I remove the self function body in here and so a foo is the simple foo takes 0 positional arguments but was 1 given, which means that each class automatically calls or given to the self keyword. It's the nature of the class definition in the Python programming language. Okay, and so we must give the or define this self object or the arguments in each class implementation of the of Python programming language. Okay, and so What about the calling the class without using the objects or this like the a sample function body? Firstly, we need to create the two classes in here like this one, def foo self and print sample foo. Okay. And we can call the maple class like this one, the def foo self and print maple foo. Okay. So we can create this as function body and m maple like this one, and so we can call the as foo and m foo function. Okay, this is the standard definition of the calling the any function from the class implementation. And so if I run this code, and then we will get the sample.foo and maple.foo. But we can also call this function as a class object like this one, foo and maple. Okay, but if I run this code, and then we will get the one error, which is the self arguments cannot be calling like this one. And so which means that in order to call this function, I should give at least one parameter with the self. But what is the self? What is the type of the self? The type of the self is the is equal to the s and m, sample or maple. Okay, and so if I run again this code, and then we will have the sample foo and maple foo like this one. But what if I change this code like this one? And so this code is also called with the sample foo and maple foo, because this self is a generalized type of the class definition, which means that it's the type of the these terms or these classes. Okay, this is the wrong or the runtime error or the semantic error, but the syntax error is not seen on this page, but in the standard form of this definition. And so we should give this time. Okay, and so in this case there is no syntax error but wrong usage. Okay, any class parameter can be given to the self. Okay, so we need to give some specific examples about the global and local variable parameters in class. Okay, class has the specific scope property, and we should give the declaration of variables heading like this one. And so we have the two scope in here like this one, global scope and class scope. Okay, and also we have the local scope in Python programming language. For example, we can define some specific x is equal to the 10, and so class sample can be given like this one, y is equal to 20. And so if I call the print x and print y, and so if I run this code, we will have the 10 and 20. Okay, but this y value is the class attributes or the variables. Okay, or the features. And so this y must be given to to these nominations. Okay, and also we can define the def foo function in here like this one, z is equal to 30, and print z can be given, and print sample or the y can be calling right now. Okay, and so if I run this code, we will have no error. But if I can write the print x in here like this one, the print sample dot y like this one, and so we will get the no error, because the y is contained in the sample y, and so by using this denomination, and so this class attributes can be calling by using these terms, and so X is also seen because it's a global scope. Okay, but as sample can be created in here like this one, and as few, if I call the as few, and so we will get the error name Y is not defined in here because this Y value is contained in this form or the class scope, but not in this case because this few has the local scope variable in here like this one. But how can we use this Y within the what the def few function? And so we should give the sample Y parameter in here like this one, and so we will get the what the every values of these terms. Well, okay, and so what about the print Z can be here? And so this Z is not defined because this few is created Z, and after the complete the whole the task, this Z is destroyed or the distracted from the what the interpreter. Okay, and so in order to use this Z function, we should given in the what in this space, or we should write a specific code within the foo function. Okay, and so this is the syntax error. Okay, and also this is the syntax error. Okay, so what about this code? X is equal to 100 class sample, X is 200, and also I can give the what the def self function in here like this one. Okay, and X is equal to 300. Okay, and so if I print the X in here like this one, and after that I can print this one, and also I can print the X as this one. Okay, and so what about, or what happened if I run this code? We will have the 200 because the class scope has the class attributes in here, and this print X is interpreted from the what the Python program, and then this is written on the what terminal page. Okay, and after that we have the global scope and global variable in here like this one, and so this is printed from the what the Python programming language. Okay, but S is equal to the sample in here like this one, S dot foo can be called in here, and so 200 is calling in the first place, 100 is calling in the second place, and S few is assigned to what the X is 300, and so this is called or seen in the terminal page. Okay, this is the sequence of the what the representation of the X variable, and so in each X variable we have the different features. Okay, even if it's the name is the same with the other one. Okay, or we can also create the instance attributes. Okay, for example, we have the class point in here with the pass arguments like this one, and so we can create the PT with the point constructor or the class variable, and then pt.x can be assigned 10, pt.y can be assigned 20, and so the print x is equal to the what these terms like this one, and so the format ptx and pty. Okay, and so if I run this code, we have the what the instance attributes. Okay, but this x is the class attributes. Okay, class possess these terms, but this is the instant attributes. Okay, what about we define the another point in here like this one, pt1 and pt1 and pt1. Okay, if I run this code, we have the what the no values about the x and y, because this instance attribute is only added to what the pt variable or the pt objects. Okay, just remember that. But if I have the point with the different name, and so this the different object, and then we will not have the possessed feature with the x and y. Okay. For example, each class objects may have different attributes. Okay, for example, class sample is an empty class like this one, and so s1 is the sample in here, s1x 10 s1y 20, and print x the format s1x and s1y. Okay, and so if I run this code, we have the s1 with the instance attributes of the x and y. But what happened if I change s2 with the s2.a is 30, s2.b is Ali, or s2.c is 12.3. okay, and so if I have this utilization, and then a, b and c can be assigned with the new variables or the new instance. Okay, just like this one. And so if I run this code, and the a, b and c is seen on the internal page, and so this s1 has the different attributes, and s2 also different attributes, but the class sample has no the class attributes. And so if you want to create the common variables or the common methods, we should define the every variables in the class implementation, not on the objects. Okay, this is why we should utilize the self definition or the self keyword in Python class. Okay, and then I can give some specific examples in here, like this one, the whole attributes, so we can use self. Okay, this is class property. For example, if we have the class point in here like this one, def set, okay, self x and y can be given, self.x can be assigned to x, and self.y is assigned to the y. Just remember that this self.x is another instant attribute, but it is in the class definition, and so this is called the class attributes. Okay, and so if I every time creating the point object, and so this point object is has possessed this x and y values. Okay, and also this function like this one, print self x and self y. Okay, and pt1 is assigned the point, and pt2 is point, pt1 set 10 20, and pt2 set 30 40, and pt1 this can be called like this one, pt2 this can be called like this one. Okay, but now we have the shared memory utilization or the shared common variables like this one, self.x, self.y. Okay, but I can only give the pt1 with the definition of x and y in the in this global scope. But if I use the self function, and so I can share the whole attributes to the class definition. Okay, so have the some general code utilization in class definitions like this one, which we call it the double underscore terms, like this one, new, or the init. This is what the standard definition or the standard generator function mechanism in Python programming language, especially for the what? For the class definition. And so if you have the any class definition like this one, it's like the constructor in C++ programming language, okay, in CPP. For example, if I use the class sample in here and with the pass, and so if I generate the what, the sample class in here, and so as that reach the what, the some specific function, even if we don't have any definition within the what, the class sample, and so this automatically what the created from the compiler or the interpreter for the Python programming language, okay. So if we have this nomination, and then we can give the what, the init function body with the standard definition of some self parameters and returns to non-value and pass, okay. But if I change the what, the self A is 10 and self B is 20, and we can call it the def this function in here like this one, okay, self, the print self A and self B, okay. And so what happened if I create the any variable in here like this one, and x, this can be called by using these terms, okay. And so 10 and 20 is seen in the terminal page because this init function, whatever the function codes or the Python codes, if we have the creation of the any variables with the type of the what, the sample class, and so this def init is automatically called, okay. And so the every object possess this feature, okay. Just like the what, the y value, for example. And 20, okay. Or we can give another implementation of the Python codes like this one, the class sample def init self with the parameters of the A and B, and self A and self B is B, def disp self print self A self B, okay. X sample can be called like this one, but in this case we have the constructor object in here, and so in Python programming language no overload mechanisms, okay. Which means that if we have the definition of the init function like this one, and so we cannot create empty sample objects like this one. Instead of using these terms, we should give the what, the 10 and 20 values in here like this one, and so x disp should be called in order to see all the results, okay, 10 and 20. Or we can assign the what, the, for example, like this one, a is equal to the 10 and 20, okay. And so we can call it the what with the default arguments like this one, and so we have the 10 and 20 in here. This is the overwritten of the x variable in here like this one, y variable, y disp can also be calling in here. And so the every mechanism is included in the what with the default argument change in here, okay. This is the simple identification of the sample example or the overloading mechanism in the class definition. Okay, so we have also given the class some specialized class in here, complex class in here, like this one, the init function body, and we can assign the real 0 and image 0 in here, which the default arguments. Real can be given the real, and self imag is imag. Just remember that this is the class attributes, but this is the argument parameters, which is given in the what, in the arguments of the what, the init function. Okay, just remember that. And so the self real is the what, the class attributes, but the real is the what, the arguments for function. Okay, and after that we can code or this the what, the self definition in here, like this one, the print. We can write the fancy parentheses in here, like this one, and I can be given in here, and format self real, self imag. Okay, and so Z1 can be created with the complex variable in here, and Z1 this can be called automatically because we have the default arguments in here, 0 plus 0. Or we can assign the what, the 10 value in here with the Z2 and Z2. Okay, and so 10 plus 0 I value is contained in here. Or we can give the what, the 10 and 20. And so this initialization can be run with the what, with this property or the class attributes property. Okay, 14 examples. Okay, so we need to talk about the what, the class attributes and object attributes in a deep way. Okay, for example, if we have the student class in here, like this one, x is equal to 10. Okay, and so this is the class attributes. Okay, because the class possesses these terms, and so we can call the print x, and so the class attributes it's calling in here. Okay, used, and so the def init function body with the name and no value, and so the self name can be initialized with the name, self no can be initialized with the no value. Name and no is the what, instance attributes. Okay, but self name and self no is also class attributes. Class attributes. Okay, def disp self, the print name is equal to the what, the no can be also given in here, like this one, the format, the self name and self no. Okay, and also we should give the print x in here, like this one, but with the some. How can we add this term? The student possess x, and so we should give like this one. Okay, as student can be created in here, like this one, the Mehmet İşcan, and with the number of 1 2 3, and as this can be written like this one. Okay, this x is calling in here, and student is created with the name of the what, these terms, and then we can write this self function body. Okay, so another topic about the classes. The class represents the contents of same elements with the specific function to be applied on these elements. Okay, which means that we may have the variables or the different type of variables stored in the class, and so by using these class properties and the function we can perform the different objects or the different tasks. For example, class complex can be created again in here like this one, the def init in here with the parameters of the real 0 and imag 0 like this one, and self real and self imag is equal to the imag. Okay, and so def disp self can be given like this one, the print plus I, the format values of this term is equal to self real and self imag. Okay. And also we can add the some def add operation in here like this one, self and z, which means that we can use this add function in order to in order to one variable to the another one, adding to another one. Okay. And for example, the results can be assigned with a new variable complex like this one. The result real can be assigned to the self real plus z real. Okay, this is the basic rule for the summation of the complex number. Okay, self imag plus z imag. Okay, and then we can return the result value by using this new variable should be returned with with this property. Okay, and so z1 can be defined with the complex 10 to 20, and z2 the complex 3 and 4, and z3 can be created right now with the z1 add and z2. Okay, z1 disp 2 and 3 can be given like this one, and so this add taking the parameter of the z, and then this self real which is the included in 10 and 20 values, and so this 10 plus 3 creates the real part, 20 plus 4 is created to the imaginary part, and so this new variable is in the complex type of these terms, and so z3 is created like this one. Okay, so in the next lesson we will talk about how can we create the or how can we overload the underscore operators, because this add function normally is included in the in the class constructor objects. Okay. Another example can be given like this one, the x is equal to 10, and so we can print the sample x in here like this one. Okay, and also we can assign the x to 20, and also rewrite the print sample x like this one. Okay, and so we can update each variable stored in the class attributes of the sample can be updated from the user or the global scopes, or we can create the sample class and x equal to 10 s equal to the sample like this one. The print as x can be reached, and also we can reach the sample x like this one. Okay, this is equal to 10, and so this instance is the assigned to the new variable in here like this one, and also we can get the sample x with the equals to 10 values. Okay, or we have some kind of nomination in here as x is equal to 10, and so def init function can be given in here with the parameters of the x, and so self x can be assigned to x. Okay, and so what about this term? The argument is assigned to 20, and so this x, or what's the values of this s times x. In this case, we will get the 20 because this x has a priority on this function because it's the local parameters or the local scope. And so this x is also what the class attributes at the same time. Okay, sample x is assigned, and so this sample x is equal to 10. Okay, so in the next lesson we will talk about first the address operation or the addresses of the class, and some detailed examples will be given in the next session. Okay.